Our lesson for today is all about proving properties of parallel lines cut by a transversal. One morning, Archie was excited to open their TV to watch the Deped channel. That time, the topic was about geometry. However, in the middle of discussion, the TV signal went wrong. So she asked her daddy Joel to check the TV antenna on their rooftop to see if it caused the signal disruption. Her father noticed that the antenna slightly moved because of heavy rains last night. As the antenna moved, Archie noticed that the antenna seemed to be similar to their topic in geometry about parallel lines cut by a transversal. Now, for our first activity, using the given figure, identify each pair of angles. Choose your answer from the box below. I will give you 30 seconds to answer the following items. Time's up. So now, let's answer the following items. For number 1, angle 3 and angle 6 are what? They are alternate interior angles. Next, for number 2, angle 2 and angle 7 are alternate exterior angles. Next, for number 3, angle 1 and angle 5 are blank. They are corresponding angles. Next, for number 4, angle 4 and angle 6 are blank. They are same side interior angles. Next, for number 5, angle 2 and angle 8 are blank. They are same side exterior angles. Now, I hope you understand our first activity. Next, let's proceed to our next activity. Use the figure at the right to complete the following statement. I will give you again 30 seconds to answer the following items. Time's up. So now, let's answer the following items. For number 1, angle 2 and angle blank are same side exterior angles. So the answer for number 1 is angle 1. Next, for number 2, angle 1 and angle 3 are blank angles. They are alternate exterior angles. Next, for number 3, angle 4 is congruent to blank. The answer for number 3 is angle 2. For number 4, if the degree measure of angle 4 is 50 degrees, then the degree measure of angle 2 is equal to blank. The answer for number 4 is also 50 degrees. Next, for the number 5, the degree measure of angle 2 plus the degree measure of angle 3 is equal to blank. Since they are supplementary, the answer is 180 degrees. Now, After studying the parallel lines and transversal, you are now ready to prove properties of parallel lines cut by a transversal and apply them in a particular problem. Let us see how it is done. Make sure that you have protractor next to you as you will be needing it in this part. For our directions, using the parallel lines, draw a transversal, or which is the line T cutting the lines. Label the angles formed as indicated by the figure. Now, using your protractor, measure angle 1 and angle 3, angle 5 and angle 7, angle 2 and angle 4, and angle 6 and angle 8. After you measure the following angles, what do you notice? Now, in the previous section, line T that intersect line A and B is called the transversal. It is a line that intersects two or more other coplanar lines at two or more distinct points. The result of the previous activities will lead you to the following postulates and theorems. These are corresponding angle postulate, alternate interior angle theorem, alternate exterior angle theorem, same side exterior angle theorem, and same side interior angle theorem. Now, let us prove the properties of parallel lines cut by a transversal. Let's proceed first with the corresponding angle postulate. Based on the definition, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. If line A and line B are parallel and line T is a transversal of A and B, then the following pairs of corresponding angles are congruent. These are: angle 1 is congruent to angle 3. Angle 5 is congruent to angle 7. Angle 2 is congruent to angle 4. And angle 6 is congruent to angle 8. That is corresponding angle postulate all about. Next, let's proceed to the alternate interior angle theorem. Based on the definition, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Now, given line M is parallel to line N, transversal P cuts line M and line N. Let's prove angle 2 is congruent to angle 3. So for this, we need to have our proof. We have our statements and reasons. For our first statement, line M is parallel to line N, and the reason here is given. Next, angle 1 is congruent to angle 2. The reason here is bivertical angles are congruent. Next, angle 1 is congruent to angle 3. And the reason here is corresponding angles are congruent. And for our last statement, angle 2 is congruent to angle 3. That is the transitive property of congruence. Thus, that is the alternate interior angle theorem all about. Next, let's proceed to the alternate exterior angle theorem. Based on the definition, if two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. Given the line M is parallel to line N, transversal P cuts line M and line N. Let's prove angle 1 is congruent to angle 3. So for this, we need to have our proofs. So we will have our statements and reasons. So for our first statement, line M is parallel to line N. The reason here is given. Next statement, angle 2 is congruent to angle 3. The reason here is corresponding angles are congruent. Next, angle 1 is congruent to angle 2. The reason, the vertical angles are congruent. Next, for our last statement, angle 1 is congruent to angle 3. And the reason here is by the transitive property of congruence. That is the alternate exterior angle theorem. Next, let's proceed now to the same side exterior angle theorem. If two parallel lines are cut by a transversal, then the same side exterior angles are supplementary. Given that line Q is parallel to line R, transversal P cuts line Q and line R. Let's prove that the angle 1 and angle 2 are supplementary. So again, for here, we need our proof. So we will have our statements and reasons. For our first statement, we have line Q is parallel to line R. And the reason is given. For our next statement, angle 1 and angle 3 form a linear pair. The reason, the definition of linear pair. Next, angle 1 and angle 3 are supplementary. The reason here is if two angles form a linear pair, then the angles are supplementary. Next, the degree measure of angle 1 plus the degree measure of angle 3 is equal to 180 degrees. The reason, that is the definition of supplementary angles. Next statement, angle 2 is congruent to angle 3. The reason, alternate exterior angle theorem. Next statement, the degree measure of angle 2 is equal to the degree measure of angle 3. The reason, the definition of congruent angles. Next statement, the degree measure of angle 1 plus the degree measure of angle 2 is equal to 180 degrees. And the reason is by substitution property. Next, for our last statement, angle 1 and angle 2 are supplementary. The reason, if the sum of two angles is 180 degrees, they are supplementary. That is the same side exterior angle theorem. Now, let's proceed to the same side interior angle theorem. If two parallel lines are cut by a transversal, then the same side interior angles are supplementary. So, the given is line Q is parallel to line R, and transversal P cuts line Q and line R. Let's prove angle 1 and angle 3 are supplementary. You need to remember that if the sum of two angles is 180 degrees, then they are said to be supplementary angles. Again, from here, we need our proofs. So we will have our statements and reasons. For our first statement, line Q is parallel to line R. The reason is given. Next statement, angle 2 is congruent. Angle 2 and angle 3 form a linear pair. The reason? The definition of linear pair. Next statement, angle 2 and angle 3 are supplementary. The reason? If two angles form a linear pair, then the angles are supplementary. Next statement, the degree measure of angle 2 plus the degree measure of angle 3 is equal to 180 degrees. The reason? That is the definition of supplementary angles. Next statement, angle 1 is congruent to angle 2. The reason here is by alternate interior angle theorem. Next statement, the degree measure of angle 1 is equal to the degree measure of angle 2. The reason is by the definition of congruent angles. Next statement, if the degree measure of angle 1 plus the degree measure of angle 3 is equal to 180 degrees, the reason is by substitution property. And for our last statement, angle 1 and angle 3 are supplementary. The reason? If the sum of two angles is 180 degrees, then the angles are supplementary. And that is the same side interior angle theorem. Now that we are done proving properties of parallel lines cut by a transversal, let us now apply them to find the value of unknown variables and the measure of angles in parallel lines cut by a transversal. For our first example, in the given figure, line L is parallel to line J and cut by the transversal K or line K. The degree measure of angle 1 is 120 degrees. Let's find the measure of angle 2 and angle 3. Again, the degree measure of angle 1 is 120 degrees. So to find the degree measure of angle 2 by the corresponding angle postulate, it is equal also to 120 degrees. Next, to find the degree measure of angle 3 by the alternate exterior angle theorem, that is also 120 degrees. I hope you understand our first example. Next example. In the figure, L sub 1 is parallel to L sub 2 and line T is the transversal. If the degree measure of angle 1 is 3x and the degree measure of angle 3 is 105 degrees, then what is the value of x? So from here, we will have our solution. So from our figure, angle 1 is congruent to angle 3, and that is by the alternate interior angle theorem. Next, the degree measure of angle 1 is equal to the degree measure of angle 3, and that is by the congruent angles are equal. By substitution property, we substitute the value of the degree measure of angle 1 and the degree measure of angle 3. We will have now 3x is equal to 105. And after that, let's apply the division property of equality by dividing both sides by 3. So 3x divided by 3 is x, 1x or x, and 105 divided by 3 is 35. So, therefore, the value of x is 35. That is our second example. Next, for our last example, in the figure, L sub 1 is parallel to L sub 2 and parallel also to L sub 3. And line T is the transversal. Given that the degree measure of angle 1 is 140 degrees, excuse me, and the degree measure of angle 2 is 4y, and the degree measure of angle 3 is 2x plus 10, find the value of x and y. So from here, we will have two solutions. So for our first solution, angle 1 and angle 2 are supplementary. So then, the degree measure of angle 1 plus the degree measure of angle 2 is equal to 180 degrees. And by the substitution property, we substitute the value of the degree measure of angle 1 and the degree measure of angle 2. We will have 140 degrees, which is the value of the degree measure of angle 1, plus 4y, which is the degree measure of angle 2, is equal now to 180 degrees. And after that, by the addition property of equality, we subtract both sides by negative 140 degrees. So 4y is equal to 180 degrees minus 140 degrees. We will have now 4y is equal to 40 degrees. Now, by applying the division property of equality, we're dividing both sides by 4. So 4y divided by 4 is y, and 40 divided by 4 is 10. So the value of our y is 10. Now, since we already find the value of y, let's find out now what is the value of our x. So for our second solution, since angle 1 and angle 3 are supplementary, then the degree measure of angle 1 plus the degree measure of angle 3 is equal to 180 degrees. By substitution property, we substitute the value of the degree measure of angle 1, which is 140 degrees, and the degree measure of angle 3, which is 2x plus 10. So we will have now 140 degrees plus 2x plus 10 is equal to 180 degrees. Now, so let's combine similar terms. 140 plus 10, we will have now 150 degrees plus 2x is equal to 180. And by applying the addition property of equality, we add both sides by negative 150. So we will have now 2x is equal to 180 degrees minus 150 degrees. And next, we will have now 2x is equal to 30 degrees. And after that, let's apply the division property of equality by dividing both sides by 2. So we will have 2x divided by 2 is x, and 30 divided by 2 is 15. So, therefore, the value of our x is 15. So therefore, the value of x is 15 and the value of y is 10. And that is our lesson for today. I hope you understand that, class. And now, again, that is our lesson for today, which is proving properties of parallel lines cut by a transversal. Thank you for watching.